Imagine walking into work tomorrow and your new coworker isn't human. A global race has already begun. 10 companies, 1 prize, and no one has won yet. To understand who's winning, we have to go inside the machines themselves. Who will build the world's first human-level robot, and what will it mean for the rest of us? For 60 years, robots could move. They couldn't think. Then AI learned to see, reason, and move, all at once. It runs on the same chips, reshaping every industry on Earth. Governments and investors have started calling this the next trillion-dollar industry. Factories need workers they can't find. Warehouses run around the clock. So companies started building something new. A machine shaped like us, built to work like us. Billions of dollars are pouring in from the biggest names in technology. So who's actually leading this race? Tesla is converting its car factories to build Optimus at massive scale. Figure AI has taught its robots to move their whole body from a single stream of thought. Boston Dynamics has spent decades pushing robotic movement to its limits and just went electric. In China, Unitree is making humanoid robots cheap enough for almost anyone to buy. Apptronik is betting on something simpler, proving robots pay for themselves in the warehouse. Today, 1X Technologies wants to bring a robot like this into your living room. Behind almost every one of these robots is the same invisible layer, the AI brain that teaches them to understand the world. Some are chasing scale, some are chasing intelligence, some are chasing price. Behind every one of these machines are engineers who've spent years teaching metal to move like muscle. But to understand who might win, we need to understand how these robots actually work. First, the robot has to see, not just images, but meaning. A new kind of AI model turns what it sees directly into movement, no separate steps in between. Its fingertips can feel pressure as light as a paperclip resting in your palm. Staying upright while carrying something fragile is one of the hardest problems in robotics. Every motion is powered by dozens of precision electric actuators, the robot's muscles. But all of that intelligence still needs power, and batteries remain one of the biggest limits. Before a robot ever tries something in the real world, it practices millions of times inside a simulation. And remarkably, what it learns in simulation transfers almost directly into the physical world. Increasingly, you don't have to program these robots at all. You just have to talk to them.
We need to recalibrate the primary sensor array on this unit.
All of this has to be built by the millions if it's going to matter. Inside these factories, robots are now building other robots. Every unit is tested thousands of times before it ever leaves the floor. Quality control here is measured in millimeters. Production rates that once took a full day now take about an hour. From here, these machines head straight into real workplaces. In some warehouses, they're already working full shifts without anyone at the controls.
Built-in safety systems let them work alongside people without a single fence between them. But for every problem these factories have solved, several more remain. Even now, no robot hand matches the dexterity of a human one. Battery life still limits most robots to just a few hours before they need to recharge. And every company is still working to prove these machines are truly safe around people. The biggest challenge of all may not be hardware, it's teaching a robot to handle situations it's never seen before. And building millions of these machines affordably is still an unsolved manufacturing problem. Even the most advanced robots still fail and have to learn to recover on their own. Every one of these problems is being actively worked on in labs across the world right now. So what happens once these problems are solved? In the factories of the near future, humanoid robots may work every shift, every day, without rest. In hospitals, they may one day help carry supplies, assist patients, and ease the load on overworked staff. At home, they may help with the small daily tasks that quietly take up so much of our time. In construction and hazardous environments, they may take on the jobs too dangerous for people. Some researchers even imagine these robots preparing the way for human life beyond Earth. None of this is guaranteed, but all of it is now being actively built, tested, and refined. So, who will build the world's first human-level robot? The truth is, no one has yet. The race is real, but it isn't finished. Whoever wins won't just need the smartest AI. They'll need the best hardware, the safest systems, and the trust of the people working beside them. This may become one of the defining technologies of the coming decades, and we're only just getting started.